Now we need to what the factors affecting. I mean, these are just the categories. Okay, and so I mean, it's a mechanism you can keep in mind either one or two, so that you can give the example in your writing answer. Okay, but the factors affecting that is important. Okay, so the factor affecting the creep, the several factors influencing the creep rate and external extent of the creep. So different different kind of the factors are there which influence the rate and the extent of the creep, how long they will be having. Okay, it will, here are some two factors, which is that stress and temperature, which are very obvious because the whole the creep will is based over the temperature and applied load, which two things very obvious, which are the base of the creep. Okay, so we have discussed in detail just in the previous slides. Okay, so here is the factors and effect on creeps. First one is the temperature, which is obvious. The high temperature accelerates the creep. If they are having the high temperature, then it will accelerate the creep. If we talk about the applied load, obviously the high stress increases the creep rate. It means the high load will increase the high stress, and high stress will increase the high, or you can say increase the creep rate. I mean, these two were the very obvious. Third one, the material compositions that also take parts in affecting the creep. So stronger the material, example the superalloy, resists the creep. If material is nature of mechanical properties like strong or tough, then it would resist the creep, and it can less affect the creeping, or you can say it will not get creeped early. Okay, grain size, if the smaller the grain size enhance the diffusion creep, and larger the grain size resist the creep. So the grain size here, what if the grain size is having the larger size, then it will resist the creep. But if they are having the smaller size in grain, or you can say the fine grain, the fine grain is very small, right? So that would not be resisting the creep. So grain size, how they are just taking part in affecting the creep. If the grain size is small, then it will enhance the diffusion creep, and if they are large, they will resist the creep. If we talk about the time, then obviously the longer the exposure, increase the deformation. Obviously, if you have the same temperature, same load, but you have kept for the long time, then obviously the creep will increase, right? I mean, three things were very obvious here: temperature, applied load, and time. But two things and if you talk about the material composition, that also you can think about, because if the material is stronger, tougher, then it may resist the creeping nature, and if the material is weak, if material cannot sustain that applied load, or they are not having a stronger natures, then it must be you know supporting the creep. Okay, or it will get creeped earlier. Okay, but if they are stronger, then it would be but one thing which is a grain size that you need to remind, you need to memorize in your head, so that you could idea whether the material size, if the grain size is a smaller, then it would increase the diffusion creep, and if they are having the larger size, then it would resist the creep. This is the things you must need to you recall, or you must need to keep into your head, so that you can recall, because it is not very obvious. You must, if you have not gone through this you know theory, you are not aware about that, what the size of grain takes a part affect taking the part into affecting the keep rate. So that if you have not gone through that, then you could be not be able to answer that. For that, you must have a, a clear idea into your head, so that you can easily answer. Okay, so a smaller size will enhance your diffusion creep, larger grain assist the creep. Okay, and rest all are just kind of factors which you can easily think about. If you talk about the temperature, obvious, it is a high temperature, the high creep, and it will accelerate the creep. If applied stress, means the applied load, and applied load is high, it means the stress is high, and the creep rate would be high. If time, for the same load, same temperature, if you have kept them for the prolonged time, then it will be having the more creep. Simple. If we talk about the grain material composition, then obvious, we are having, if the material natures, it depends on the material nature. If material can resist the more, it means if material is stronger, then it can resist you know all the kinds of loading and temperatures. That's why it will decrease the creep, or you can say it will resist the creep. But for the grain side, we must have to keep it into head. Okay.